multiply that times the top, and then put all of that over the bottom squared. And y'all told me not to prove this, right? Y'all told me y'all didn't want to see me prove this, right? So I didn't prove it. You're taking it on faith. But the proof is very similar to the product rule. There's a hidden zero, and all this stuff happens, and you make it work. So it's a little harder, though. Right, isn't that just the formula? Now derivatives. So when I look at this, I always like to look at the two derivatives I need to take. I need to take that derivative and that one. The one on the right, that's pretty easy derivative, right? You can just do them one by one. So derivative of that's just going to be 3x squared. This is the one that requires some work. So depending on you, depending on how comfortable you are with this, you might actually need to do scratch work on the side. You might need to like start a whole new problem and just ask yourself, hey, how would I do the derivative of that, right? Because that's what you need to do. And then maybe work that out like a product rule over there. And then whatever you get as your answer, just come stick it right here. Some of you will need to do that, and some of you will be able to do this just while you're working through. It all depends on you, how quickly you can pick this up. So I'm going to do it as scratch work first. This would be the derivative of x times sine x plus the derivative of sine x times x. So I'm doing derivative of the first one times the second plus derivative of the second times the first. I'm using product rule over here, right? There's my product. What is the derivative of x? 1. 1 times sine x is sine x. And then derivative of sine x is cosine x, but then times x. So I'm going to put that x in front of the cosine x, right? Do y'all see that's just this, right? That's just this derivative. What does that still need to be multiplied by? All that, right? Okay, so when I write this down, I'm going to have in parentheses that answer, sine x plus x cosine x. That's the answer from over there. Still times the x cubed plus 1. Minus, now this derivative we had said we don't need to really work on. We can just see it and not have to do product rule or anything, right? So derivative of that was what? 3x squared. And then I still have times the x sine x. And then all of this divided by the x cubed plus 1 squared. Am I done with the calculus? Yes. Have I taken all the derivatives?
Yes. Wait, yeah.
Yeah, right? I did the derivative of this, right? I did that over there and brought it here. Times that, minus derivative of that. Yep, did that, times that, and then all over the bottom squared. Calculus part of the problem is done. Okay? All right. Why don't you try this? How about we do this? This will be an in-class group bonus question to add 5 points to the test you just took. All right? But you got to get it right. But you're allowed to work together. All right? It's not necessarily a hard problem. It's just I want to reward y'all for sticking in this right now, okay? So, yes. Pardon?
The person next to us?
You want to change? That's rude.
No.
That's rude.
That's not what I meant.
No, what are you saying? What were you saying?
As in a group or just the person next to
I don't care. I just don't want like y'all all saying, "Hey, everyone, here's the answer." You know, like just work together. You can turn around, check with each other. If you want to move the tables, that's fine. Okay. All right. Look, here's the function. F of x is going to be x squared over 1 plus x cubed. Let's make it instead 3x squared on top, sorry. 3x squared over 1 plus x cubed. If that's your function, I want you to find the equation of the tangent line at x equals sorry, can I change one thing to make your life easier? Can I change one thing? Change that 3 to a 4. Okay, that'll make your life a little bit easier, believe it or not. At the point, I want this to be a point now. Let's go with 1, 2. All right. I'm not giving you like 30 minutes on this. I want to see what you can do. I can't see more than 10 minutes. So get to work. All right? Your answer should be the equation of a tangent line. Right? Do this on separate paper. Do it on separate paper because you're going to tear it off and you're going to turn it in. All right? Don't put it on the back of your notes. Yeah, because you want to keep those. All right? All right. Have at it. Y'all good? You got something? Okay. Hang on to it. I'll collect them in a minute. You got 4 minutes.
Would you like to be part of group M, then X minus
Do you need some help? What's wrong? What did you do?
math?
You found the derivative?
Yes.
What does the derivative give you? Like, go back. What is the derivative? Geometrically. What is the derivative of slope at some value of x, right? At what value of x? Well,
At 1.
at 1, right?
Also, does that mean after we find the derivative, we plug a 1 into the x?
And that would give you the slope of the tangent line at that point.
Right.
Anybody else have a question?
I have a question, yeah.
Yeah? I'll come over there in a minute.
So if the slope is 0, it's just gone, right? You don't distribute the 0?
Is that what you got? Yeah, so it kills off the right-hand side, and all you get is that 2. The 0 goes first, and then the 2 comes over, so you have y is 2?
Y is equal to 2.
Yeah. I'm not saying that's right, but I haven't done the problem, so hold on, I'll be back there. Yes? What's your question? You feel like you got the derivative right? No? So you did, all right, so you're doing the bottom low derivative of the top minus high times d low. Okay, so that's right, over the bottom squared. That's good. Your derivative's right, but what does it represent? Your derivative, right, the derivative of a function at x is the slope of the tangent line at x, right, at whatever x value you want, right? What x value are we looking at here? 1. So you got to plug 1 into that, and that'll give you a number, pardon, for all the x's. And that'll give you a number. That number is the slope of your tangent line. Once you have the slope, then you come up with the equation. Make sense? Yes, exactly, exactly. Man. Who else had a question? Did you have a question? No? You feel like you got it? What'd you get? Okay, so we're going to see. I haven't worked it out. So what was your question?
We got it.
You feel like you got it?
I have one question. But the derivative. So if this was our like if this was
2 minutes.
final thing for the limit, like if this was a limit like x going to a, but in this case our a is the derivative of 1.
Yeah.
So when we get our answer, we let y
Be 1. That'll give you a number that's your slope of your tangent line. Then you go into the y minus formula to get your equation of your line. See? All right, we got 1 minute.
We're still trying to figure it out. The derivative.
You good? Yep. Okay, if you're ready to turn it in, I'll take it.
I checked my answer. I didn't.
You checked it? All right. We got all sorts of different answers. This will be interesting.
I wrote it in both forms. Does it matter?
No, I'm okay.
I'm just going to show that. Because this one, it doesn't tell the equation. It just shows it.
Yeah.
So I just plugged in the actual equation I got and see.
You drew the same line?
Yeah.
Yeah, okay. Well, that should make you feel good.
Yeah.
Yeah.
It just like shows that I was right.
Yeah, exactly. So the formula you used, right? That formula?
Yeah.
Are you using the slider on that so you can move it around, or?
Yeah, I used a slider. And just,
Pardon?
I said A to whatever it was.
Yeah, okay. All right. Wait. All right, you're gonna start losing points. Like losing your what it's worth. All right, I can give you 30 seconds. 30 seconds. 10, 9. All right. Done? Okay. Anyone else?
M times x minus x1, so y minus it equals 4
4 times x minus, oh, I can
Just
do
leave it like that. Just leave it like that. You don't need to clean it up.
one.
Nope.
Okay.
Yep. Because that's the equation of a line. So as long as you have the equation of a line, you're done. Was there anyone else?
Oh wait, my name.
You didn't put your name? Go through it and find it. All right.
I don't know if it's right, but there you go.
Okay, you good or
I don't even think I'm.
you want to turn in? No? Okay. Yes? Okay. All right. Do I have everybody's? Ooh. Do y'all want to go over it? Yes. Okay. So look, let's not lose sight of the fact that if you're given a function, the derivative is just a new function that will give you the slope of the tangent line at any x value you want, right? So we have some function and it has a graph, whatever it looks like. And we would like to go to this point on the graph and we would like to find the equation of the tangent line. So what I'm going to do first is I'm going to find the derivative, which is going to create a formula that allows me to get the slope of the tangent line. So the derivative of this is, and I'm going to follow my formula, it's the derivative of the top. What's the derivative of the top? What's the actual derivative of the top? 8x times the bottom minus now the derivative of the bottom, 3x squared times the top, right? Notice I did not use parentheses here, but I did use them here, right? I had to do that because this is two terms, and if I multiply these, the 8x has to distribute. Here, these are not, there's no additions and subtractions, so there's no distribution, so there's no parentheses necessary. I could put parentheses, but it's overkill. All over the bottom, squared. Okay, so that right there is a formula that gives me the slope of the tangent line at any x value I want. I'm interested in the x value of 1. So I'm going to just replace the x's with 1. F prime of 1, this will be 8 times 1, and then 1 plus 1 cubed, then minus 3 times 1 squared, times 4 times 1 squared, all over 1 plus 1 cubed, all of that squared, right? That's just me replacing all the x's with 1. So I should get 8, and then times 2, then minus 3 times 4, and then over 2 squared. So the top is 16, take away 12, all over 4, and that's 1. Okay? So that means the slope of our tangent line is 1, right? Now what we need to do is find the equation. So to find the equation, we use that formula y minus f of a equals the slope of the tangent line at that point times x minus a, right? Now here a for us is 1, right? A is 1. And f of a is this value, the y coordinate. So this should be y minus 2 equals the slope of the tangent line at that point, which we found to be 1, and then x minus 1. And, that's good, but, you could go a little bit further. Distribute a 1 through, which just gives you x minus 1. And now add 2 to both sides. So y is x plus 1 is what it's looking like.
If we had left it as the y minus 2.
Right here is fine. Because that's the equation of a line. I mean, I can't argue with you that that's not the equation of a line.
You almost got it right.
If almost,
Partial good? You're Russianist. Yeah. We fixed their problem. Yeah.
we'll see. All right, so let me graph the original function. I know we're about to go here. There's the original function. And what we wanted to do was go to the point 1, 2. Okay, see that point right there in green? And if I graph the line y equals x plus 1, I should have a line that goes through that graph at that point and is tangent to the graph at that point. That looks pretty tangent to me. What do y'all think? That look tangent to you? Yeah, that looks pretty good. So now we have these new rules, right? The product rule and the quotient rule. So for Thursday's homework, please do the homework from 2.4. Do as much as you possibly can. We have come to a point where if you have weaknesses with the power rule or the product rule or the quotient rule moving forward, next class, if any of those are confusing to you, the next rule, the hardest rule that we're going to learn, the chain rule, you can't do well with the chain rule without a comfort level with product and quotient. So do that homework, all right? All right, one last thing. On Thursday, I have to end class. I know you're going to be upset. I have to end class at 4, okay? I have a required training for a hiring committee that I'm on, and they only offer it on Thursdays at 4 o'clock. So, and they only offer 2 trainings in the summer, so I have to do it. I apologize ahead of time. Yes. 2.3, no, we did 2.3 last time. 2.3 was the basic differentiation formulas, the power rule. All right, everyone have a good day.